best behavior the next couple of days, okay? All right, now, let's begin. Now, I'm making a video, my first video here without a tie. I'm going to be a rebel. Rashid is my role model, okay? And now, I use my tie for lunch as a straw. And I feel like I just sucked all the food up through it because it's all, just picked it up yesterday, spent like, 2 dirhams getting it cleaned, and then I wore it, and I really did. I use it as a mop, okay? I mopped off my plate. All right, so what I want to do is, I want to say this. So tomorrow we're doing the molecular modeling lab. All right, now, I have several videos. From last year, I have molecular models 1, 2, and 3, molecular geometry part 1, 2, and 3. I'm going to rename them and put the approximate date on them. I think it was done in December, so December 2013, and these are going to be November 2013. So I'm about a week or two ahead of where I was last year. So, right. So you've got to look at those, because you've got to come in here on Wednesday ready to work hard, because, you see, let me tell you something about how I teach, which you may not be familiar with. It might be a little bit of an annoyance that you're not aware of, maybe if I explain this. There's something called the flipped classroom. And in the flipped classroom, all you do in class is grade activities and you play and those sorts of things, yeah? And then at home, you do all of your schoolwork and your book work and things like that, right? Well, that's what I try to do. So I put all the lectures and lessons where I'm up in front of the classroom talking, where it's not boring, but it's certainly not a lecture, but it's not a lot of activities. I put that on the computer so you can do that all at home. So you've learned a lot of the basics already before you come in here. And then I don't have to do any of that in class, so you learn a lot of it on your own. And then all of that is reinforced and connected through the concept of activities when we're in class. Clear? And that's what I'm shooting for. So, when we get a little bit more of the basics down, what I'm going to be doing is, we're going to be doing lab 24/7. And that's all we're going to do. And you're going to have to do everything else on your own. Because it's not like you don't have a textbook. It's not like you don't have every lesson on YouTube. It's not like I'm going to be never filming another lesson, but we're going to be spending a lot of time. So you're going to have to do a lot of work on your own. It's going to be a very unique experience in education for you. All right, now, so I'm going to make a video now, and it's going to be like a little bit like, you're missing step 1, 2, and 3, and we're going to be doing step 4 a little bit, but not bad. I'll try to make sense out of this. This is what you're going to be doing tomorrow. Let's see. Could you bring me that tray, Andrew? There's a black tray down over there. Okay, you see that black tray? Could you bring that up here, please? Now let's do a problem. Okay, thank you. Let's do a problem. Let's start off with. Thank you. Let's start off with an easy one. Okay. We'll start off with an easy one. All right. Beryllium chloride. All right. Now we're gonna look at beryllium chloride as if it is a covalently bound molecule, and we're going to look at the geometry of beryllium chloride. Okay. Now there are several steps to do this. The first step is you write the ball and stick model. That's just a metaphor for you simply identify the central atom and then you attach with a line the other atoms around the central atom. Easy? Okay. So what you would do is you'd say, obviously, chlorine is going to be on either side of the beryllium. Clear? Step 2. Step 1. Step 2. You write the total valence. You write the total number of valence electrons available in the problem. Now, anything in group 1 has a total valence of 1 electron. In other words, the S and P electrons. What about group 17? What's the total valence of group 17? 7. Wow, you guys are good. Very good. Excellent. What about group, let's go crazy, 15? How did you do that so quickly? It's a little weird. Are you guys like from Earth? You are, right? Fatima, you're not? Excellent. Okay. Thank you very much. Okay. It's a little scary. Okay. Excellent. All right, so you write the total valence, so you just add them all up. 7, 7, and then 2. And what is 14 plus 2 is 16. Yes? Step 2. Easy? Step 1 is what? Ball and stick. Step 2 is valence. Step 3 is... How do you know that?
I wrote it down.
Oh, from the... Oh, because I gave you a chance to look at the PowerPoint before we started class. Okay. So, 2 and 2. See, each line represents 2 electrons, correct? And we have a cameo appearance. I've been driving her crazy, by the way, this whole entire week. But what would you like?
Augustina.
Augustine is here from Argentina.
Photo, please.
Photo, please.
Individual photo.
Individual photo, please. Okay, excellent. All right. Now, excellent.
Thank you.
Okay, now, so I'm going to subtract off 4 because I have 2 bonds. Each line is 2 electrons, a pair of electrons, correct? So that's going to be what? 12, right? That's step 3. What's step 4? You ready? You want to write this down, or do you remember it? You ready? Okay. You want to satisfy the valence of all outer atoms. How many electrons does the nearest noble gas to chlorine have in its valence shell? 8. And what's the name of it?
Argon.
Argon. Notice I didn't say the O word, like Voldemort, but with an O. We don't say the O word, the word that must not be used. The O word. No, I'm being, yeah. The O word. The O word for 8, we don't say that word. Yes, Aaron, osteoporosis. You are on target. Yes. Okay. Yes, the O word is osteoporosis. Exactly. Very good. Excellent. Now, so I've got to put 6 here and 6 here because there's already 2 there, right? Those 2 are claimed by the beryllium and the chlorine, right? Okay. Yes?
Yes.
Okay. Now, is that it? Right? Can you see that O at the 0 at the bottom? Okay. No, you can't. So I'll move this. Oh. Okay. So is it done? Yes, it's done, with a little bit of a caveat here, and that is that, look, this is the rule. Are you ready? Rule. If the central atom is a metal, it can have less than 8, and oftentimes it does. Can you have a covalent substance with a metal? Of course you can. Right? It's weird. Yes, all right, fine. Not a lot of them, but you can have them. Right? Okay. It has less than 8. Normally, it usually does. The next one I'm going to do has 8 as well, is less than 8 as well. Okay? Easy? Yes? Okay, so it can have less than 8. If the center one is a non-metal, what's the rule? It has to have 8. It has to have what? Say it again.
At least 8.
Say that again, Aaron. Mr. Osteoporosis. They called him simply the O-man. Okay. Yes, O-man. We have Z-man. I have Z-man in the last period. And we have O-man. Yes, Mr. O-man.
It must have at least 8 electrons.
It must have at least 8 electrons. Excellent. And that's it. Now, are there any excess electrons? Are there any unbonded pairs of electrons around the beryllium? There are? No, they're not. Taking the hints, right? No, there are not. No. No. Those aren't the droids you're looking for. Okay. So there are, so what would be the repulsion of those two bonds? Would they be 180 probably, right?
Yeah.
Right? Valence shell, electron repulsion theory, right? So what would that look like? I have three atoms and they are linear, correct? So it would look like this. I have all of these really nice things here. I can't find them. I can't find it. It's here somewhere. Here it is. Right there. You see that? Now, tomorrow you're actually going to put atoms on the end here. But I'm making this look like the drawing, see? Where on the end, see the toothpicks? Yes? Those are bonded electrons. So there is a atom that is understood to be at the other end of each of toothpick there. Right? On either end of each toothpick, there is another atom understood to be there, correct? So that's linear. So that's what that is. Right? You see that?
Yeah.
Okay? What do I mean by that? For instance, this. I'll do that these are unbonded pairs, see? These little pipe cleaners, I think. Kind of cool, huh? Okay. All right, you'll see me put those together. I did that last period, okay? Now, right. So, that's that one. Let's do, shall we do another one?
Yeah.
All right, I'll do two more. I'll do another one that's a little bit regular, and then I'll do a really kind of a funky one, okay? All right. So Al, Cl, 3. I didn't really write that very well, did I? Okay. So it's going to be Al, right? Is that okay? Are you with me? You all right? Everything's fine? Oh, we have another student joining us in another couple of weeks. They were here last year. They're coming back?
Kaylee.
Don't say the name. I don't want to do names on the internet. Okay, we'll talk about it later. Okay. So anyway, so this is going to be Al, Cl, Cl, Cl. Okay? You get that?
Yeah.
Okay, so what's the valence? 3, 7, 7, 7.
Yeah.
Right? What's that add up to?
24.
25? Yes, 25. Okay?
7 times 3.
My hero's back. The man without the tie. Okay? Rashid. Okay. So 24. So let's hear. Here's the 24. Okay, let's see if that's on. Okay, it's on. Okay. All right. So I'm going to draw. I'm going to subtract off 6, right? So 18. Right? Clear? Okay. Now, so that's 18, right? So I have to satisfy the valence of the outer atoms. Now, remember we said the center atom, if it's a metal, is usually less than 8. Can be less than 8, right? If it's a non-metal, it has to be at least 8, right? But the outer atoms have to be exactly 8. With hydrogen is also satisfying a noble gas structure, helium, so that's not going to be 8, but that's why we don't use the O word, okay? We don't use the Voldemort word, osteoporosis, okay? We don't say osteoporosis for 8, right? O man, okay? So, I know, it's difficult teaching in here because we have Oman right south of here, okay? Okay, Oman is where Oman is from, okay? Now, so I'm going to satisfy the... Okay, you got it? Are you okay with that? Okay. So, aluminum chloride. Now, what kind of geometry is that? Do you know? Can you look up your Friend of Oman.
Oh, yeah.
Yes, thank you. Can you look up friend of Oman? Can you look up what geometry this is? No unshared pair of electrons. So 3 bonded pairs and 0 unbonded pairs. Yes. Yes. Man who sits in front of Oman. Do you have an answer? Man who sits in front of Oman. Okay. Trigonoplanar. I am Robbie the robot. Okay. Okay, you sounded like Robbie the robot. Okay. And that's correct. Man who sits in front of Oman. Okay. That's what it is. Trig, right? What would the angles be for that? 120. 120 degrees. Yeah? You see that? Because in terms of valence shell electron repulsion theory, okay, then that is going to be, that's what's going to happen, right? Easy? Yeah? All right. Let's do one more. I promised you a funky one. Okay? 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 So let's do one, and then we're done. Okay? And then I think you guys are ready for the lab. And there's going to be some challenging ones on tomorrow's lab. I mean, it's no joke. Okay? So, let's do BRI3. Major funky, major covalent, all halogens, obviously all nonmetals. Yeah? Kind of crazy, huh? Okay, Fatima, try to remain calm. Okay? Okay? Right now. Remember you've had heart surgery, you want to stay calm. You don't want to overtax your heart. Okay, Fatima? Okay, so now, so do you see what's going to be the central atom? Even though they all need one bond, obviously what's going to be the central atom? Bromine. Okay, so it's why? Is that what you said to me? Why? Did you say why? Well, because there's only one of those and 3 of these. Yeah, exactly. You give it to my Kia man. Okay. Did I say that out loud? Sorry. Okay. That's an H. That's an, I know. I can spell. I know. He's a bad speller even when he's making bonds. Okay. Okay. All right. You're all right with that? So what is the total valence? Now don't all say it at once. You know that I feel like I'm at the trauma recovery ward in a local trauma hospital here. Don't all go crazy. So 4 times 7 is 28. 1, 2, 3. That's going to be 6, right? Yes. Excuse me? 1, 2, 3, 4. They all have a valence of 7. 4 times 7 is 28. Okay? Minus 6 is going to be 22. Correct? Excuse me? Why did I subtract 6? I'm subtracting the total electrons. See, all this is credits and debits. You got to take into account all of the electrons. So the total electrons you have, those are the ones that you have to, those are the only electrons you can use, right? They have to satisfy the valence, bonds, etc. Okay. So I subtract 6, I'm left with 22. Now, I'm going to put it around each one 2 electrons, right? Right? So that's another what? That's another what? 3 times 6 is 18. Where are the 4 going to go? There's only one place for them to go. Around the center. So what geometry has 3 bonded pair, 2 unbonded pair? What geometry? You know? A T. Yes, I'm just looking for a T. I'm looking for a T. There it is. Is that it? Yeah. Okay. Now notice that this comes from, I don't have it. Where is it? Here. You see this? See this? This is phosphorus pentachloride. Okay? You see that? This is called, it's on the last film that I made last period. This has 5 bonds, right? 3 of them are in the same plane. You see that? 3 of them? Yeah. Kind of like this. Right? And then there's 2 that go straight through, right? You see that? Yes? If I take 2 off, 2 of these guys off, then I have this. I have this. Okay? I have this. Right? So these non-bonded pairs go in the place of those bonded pairs. So that's what I have. That's a T. See? Yes? So this non-bonded pair, and this bonded pair are approximately 120 apart. Right? You see that? Okay? So that's a T. See that? Hey, we're done. Okay? All right? Any questions? Preguntas. You're all right? Okay. Have a great, hey, be careful out there. Best foot forward Tuesday and Wednesday. Okay? Excellent. Can you wear a tie the next 2 days, Rashid? Okay? All right. Oh, let me put this up. It didn't all come out. So I'll put that up and I'll leave that on for 10 seconds. All right? Are we all set? Are we off?